Hello and welcome everyone to today's Association for Manufacturing Excellence webinar titled Poka Yoke, Creating a Culture of Zero Defects. I'm Jerry Strohmeyer, the Education and Training Program Coordinator for AME, and I will be your moderator. Today's presenter is Bruce Hamilton, President of GBMP, known to many as the Toast Guy for his leading role in the best-selling video, Toast Kaizen. Bruce has been a student and passionate advocate of TPS for over 30 years. In 1986, he led his company from large batch production to single piece part in information flow. Poka Yoke was a key enabler to this transformation and also a key to changing company culture. Bruce has recently been inducted into the AME Hall of Fame. So congratulations, Bruce. Before we start, just a couple of housekeeping items. You will be in listen-only mode throughout the webinar. You will see that you are muted on your attendee panel on the right side of your screen. If you have questions during the webinar, please type them into your question area in the attendee panel and click on Submit. We'll review the questions at the end of today's presentation and answer as many as we can. When you log off today, please check your email inbox, and it will be an invitation and link to fill out a short webinar attendee survey. Please take a few minutes to complete the survey today, as your feedback is very important to us to improve future webinars. Bruce has also graciously agreed to provide a PDF of today's presentation. We'll be sending that along with a recorded link for a webinar replay to each of you next week. Now I am pleased to introduce Bruce Hamilton, who will present Poka Yoke, Creating a Culture of Zero Defects. Take it away, Bruce.
Thank you, Jerry Ann, and welcome everyone. I wish I could see each and every one, but I'm just staring at a screen today, and so are you. So welcome to Poka Yoke, Creating a Culture of Zero Defects. You're going to see at the end of my presentation, at the very end, that my screen name is actually Poka Yoke, without a hyphen. They don't allow hyphens in screen names. And I chose that at a time but probably not too long ago, maybe 10 years ago. I didn't have to have any numbers or letters after it because nobody else was choosing it. Turns out it's an idea that doesn't get a lot of airplay. It's just funny after 30 or 40 years, because it was one of the key items, you know, the two pillars of the Toyota production system. Got JIT on one hand and Jidoka on the other, and Poka Yoke is a key component of this idea of Jidoka being able to never pass a defect. Basic idea is to be able to confirm quality at the source. So I came upon this idea, this thinking, when I was in manufacturing, and pretty soon it became apparent to me that nobody was really talking about it. At one time, I think we had more employees in our organization that knew what a Poka Yoke device was than perhaps the rest of the East Coast. And that's changed quite a bit, but I think not enough. Not enough. So I'm happy to be able to talk about this device, this idea today, Poka Yoke, which means I think the direct translation is without mistake. So and the first slide here has got sort of a balance between a technical part of this and a social part. I'd like to cover both of them, because both of them are important. The technical part really creates the system, and it's extremely important. It's necessary but not sufficient. The social part is the part that makes it possible for this particular system to be effective. So on the one hand, you could have, let's say, a quality system where you have lots of tools in place, but on the other hand, be missing a quality culture, you know, let's say where people are afraid to report a problem, a particular defect. So both of these are extremely important to making Poka Yoke or mistake proofing an important part of your improvement process, and I'll cover them in that order. I'm going to talk about the technical part first, and then the social part. Maybe I'll weave back and forth between the two of them. So let's start out here. Poka Yoke technical side. This definition comes out of Shigeo Shingo's book. There's a couple of books I'll reference along the way. It's any device which provides either prevention or detection of mistakes. So it would be nice to be able to prevent a defect from ever being possible. And above, in that slide above, the picture above, you see there's a fixture which will only hold a part in one way. Can't put that part in upside down or backwards, only fits one way. So we might call that a prevent poka yoke because it prevents the possibility that the mistake could ever occur. And below is a detect poka yoke, which sorry, is detect poka yoke. It doesn't actually prevent the defect from occurring, but it prevents the defect from being passed to the next process. So there's a piece of material there which is maybe slightly oversized and it won't fit through the mating part. So that's a detect poka yoke. So the key components of this, and this was noted by Mr. Shingo, the guy who pretty much brought these ideas to our attention, that we want to have 100% inspection. As I thought was, you can't get to zero defects unless you have 100% informative inspection, immediate feedback. Like to know immediately if things are wrong, and ideally we'd like it to be a prevent poka yoke so that we can't make the mistake in the first place. And the third, which I think is often overlooked, is this should be real simple and low cost. And both of the examples I give you here are pretty simple and low cost. Sometimes folks feel that machine vision is the only way to go, and that's probably the last thing to look at. We want to look for easy ways to prevent the possibility that a defect would be passed. So ideal condition, don't ever make a defect, but also the sin is actually when we pass the defect. So poka yoke is there to prevent a defect from ever being passed. There are so many different types of detection. These, once again, are detailed in a number of books, and I may mention those in a moment. But there's different ways of trapping mistakes. So in the above example there, you see pins on a die plate that only allow the fixture to only be mounted one way. Or there's a template there that allows you to see that all the parts have been added. Or there's a more elaborate device right here which prevents someone from, it only shows electrical continuity if the switch has been wired the right way. And here's a real simple one here which prevents the wrong parts from being pulled. This would be a prevent poka yoke. It absolutely prevents the wrong parts from being pulled. There are so many different opportunities to make mistakes, and arguably the best mistake-proof device is the one that's designed right into the product in the first place. But in reality, many products and services kind of are sent out to the service providers with the opportunity for mistakes possible. These can be done. So there's many different ways to probe the part or the information to be sure that that it's correct. So I've listed a source here. That handsome young man there is me back in 1989, and poka yoke was a big deal to me back then. There with my library, and I chose to pull out the Poka Yoke book. If you haven't seen this book, it's a really good book. It was originally published in Factory Magazine, I think back in the 1980s, and then it was compiled. It's available on Amazon. Maybe one of those books you can get for 15 cents, but it's a really good book. It has lots of different examples of Poka Yoke devices, and it also has a little bit of the, the paradigm-changing thinking, which is necessary in order to make Poka Yoke possible. But I think its major contribution is it gives you a lot of ideas. Now, the caveat is that all it does is give you ideas. That the actual devices which are going to work in your organization are the ones that are going to be in context of your employees' work. Your employees could be office employees, it could be factory employees or warehouse employees or drivers, or just about any function has a different venue, and the context is important to the people who are doing the work. They're the ones who will know where the mistake is being made. They're the ones who have the best context for coming up with that simple device, which is low cost, which provides immediate feedback, and ideally provides, a prevent type of poka yoke, but at least detects the defect before it can be passed on. So that's the basic idea of the technical side of Poka Yoke. It's not, it's not tremendously difficult, but it's really, it's a problem-solving process that's a little different than, let's say, just has an extra thought to it above and beyond a basic, 7 step problem-solving process. And I wanted to share this with you just quickly. The idea being that if mistakes are being made, first of all, there are conditions which, are likely. I don't know if you can see this on your screen, but things that can happen which will cause a defect. So a part can be broken or damaged. It could be missing in operation. You can have an extra part. It could be foreign material. It could be assembled backwards. It could be not aligned. There could be a missing operation. There's lots of things which would describe that defect. And the very first step with Poka Yoke, like just anything else, is direct observation. Do we actually have a good image in our mind of the problem that was caused? If we don't have that, we really can't even take the next step. In fact, oftentimes when there's a problem, we don't bother to go back and take a look. In fact, I know in my own factory, we had an example where there was a leak. There was a leak in the product. It was a product which couldn't leak, and the assumption was made that that factory employees forgot to assemble an O-ring. They'd miss an O-ring every once in a while. That seemed logical. Only problem was nobody actually observed. So we designed a lot of fixturing to make it difficult, or if not impossible, to assemble the product without the O-ring. And then sometime later we discovered that it was still leaking, and when we actually got some samples of the real product, we found it was leaking because the O-ring material was not working in certain environments. So it's a good idea to get your mind wrapped around the right problem before you start. Oftentimes we jump to the assumption that if there's a defect, it's something that was caused in production. First of all, get your facts straight. And then the rest of it is, I'm going to walk through this with a particular example. But if we were running through this then in kind of a counterclockwise fashion, we'd say, well, let's try and get this thing located in time and space. What is the defect? Where did it occur? When did it occur? Let's try to understand as specifically as we can the examples where this happened. The interesting thing here is that defects that arise from mistakes are not necessarily things which are happening every day. Assemblers, or it could be somebody in an office as well, somebody who is working with information, they worry about those mistakes 100% of the time, but they only happen once in a while. So the idea of just standing and watching to see, you'd have to be kind of lucky to be there when the mistake occurs. So having the persons who are at the point where the mistake is occurring, having them in the right frame of mind to be reporting the occurrence of the mistake is super critical to making this process work. So we're trying to understand where we discovered the defect and where it might have occurred. Next thing would be to write down to gain an agreement of what is supposed to happen, and this can be a gate as well, because sometimes when you get to this gate, you determine that, well, our first problem is we don't have a good standard, or we have multiple standards. We have a drawing that says do it one way, and we have an instruction for a fixture that says do it a different way. So we've created an impossible situation for the person doing the work. Once again, then we got to go back and backtrack to that and say, well, how can we fix that? Because if we didn't have a standard, it's hard to say that there was a mistake. So let's say that we work out the standard, then we want to go through, and this is the critical step, well, what actually happened? What went wrong? Where are the areas where things could have gone wrong? And there are once again, there are some red flag conditions. There are things where these things could happen. You'd see these in the Poka Yoke book that I referenced on an earlier slide. You'd see them in another book, which I'm going to mention later. And trying to nail down the exact point, or points, because there could be multiple points, where a mistake might have created that defect to occur, is the critical part of mistake proofing. You're backing off closer and closer and closer to the point where there likely could have been something which is, let's say, non-standard. Something that happened on this particular day, in this particular situation. And as you can see, without having really good participation from the frontline team member, from the person who's doing the work, this becomes problematical, because this is, we're asking where, when, why, and how, but we're kind of laying off the who question, because that's always what happens when there's a mistake. We're looking for somebody whose fault it was, and we have to be careful here, because if a mistake has occurred, our frame of mind has to be shame on us because we created a process where a mistake could be made. And then there's the why question. Now that we've nailed down a couple of places where this mistake might have occurred, now we can do some root cause analysis. And then we can start talking about, brainstorming about how this can be corrected, and we can put a countermeasure in place. And when we test that countermeasure, so we've moved through our PDCA cycle, but we've moved through in a way that's respectful to the people who are doing the work and absolutely requires, their active participation. So as things happen, something happened just today, we now get that piece of information, because those are the critical points that make this work. So let me run through this with a specific example. Okay, here's a defect, and this relates to a harness that a customer returned to us, which wasn't a good thing. And the customer pointed out that the harness was designed so that it could only install in one way, and they'd asked that a plug be installed in a particular position, and sometimes that plug wasn't there. And this was bad, because this was their mistake-proof device to prevent the harness from being inserted backwards. And once we provided that without the plug, it meant that that the customer could also make a mistake. So this is unfortunate, but it had happened at a point outside of our factory. So you see in this where the arrow is pointing right here, the first idea was, well, let's just make that plug dark. We're going to put a plug in there. We're going to make it dark so it's visual. Once again, we were making an assumption that, well, somebody forgot to put it in, and if we can see that, then maybe that's going to fix it. And in fact, it didn't. It didn't. There were still examples where the harness would show up the customer and it was missing the plug. And at this point, we decided this is where we need to be looking at mistake proofing. So we understood what the defect was, but we didn't know where it was coming from. We went through this process. First thing we did was and the green cards here indicate, let's say, steps of a particular standard. And we had a decent standard. Okay, the harnesses were assembled, and they were assembled in a way to avoid the plugged area, and then they were checked multiple times. This is Mr. Shingo's point that infinite inspection is not the solution to zero defects, but still, in spite of inspection, the plug would sometimes be missing at the customer. Okay, so the next step was, okay, we have a standard, we can agree on that standard. We have these steps. Now let's talk about what's actually happening. These were not things all of which could be observed in the time frame that we needed, but there was information that was provided by the people who did the work. And this was really critical. This was the essential part. Someone said that occasionally the plug would be supplied, the connector would be supplied without the plug, that our supplier would forget to put the plug in, that maybe they saw that, or maybe it wasn't forget to put the plug in, maybe it had fallen out on the way. Someone else noted that on occasion when you inserted the wire into the harness, you might have accidentally pushed that plug out, or it might have just loosened the plug. So then we confirmed that. We actually tested it, and we said, sure enough, if you accidentally push the wire into the wrong part of the cable, wrong part of the plug, you will loosen the black plug. Won't come out, but it's loosened. And then again, this was conjecture. The plug might fall out in transit to the customer. But we had some specific points where we could test. And then we started asking questions about why this would happen. Well, how could a person accidentally push the black plug out with a wire. How could that happen? What could we do about that? And once we defined these particular points, we came up with some creative solutions. I say we, it wasn't me, it was the operators, the folks who were doing this. What could we do about those non-standard occurrences? And one thought was, well, we could redesign the connector to mold the plug in. Well, that wasn't really low cost. That would have made it very special. This was a standard plug, and trying to mold that plug in probably didn't make sense. We considered it. Then someone suggested we create a template, and you may recall right at the start of the technical part of this, I said, you know, a template is something that can prevent a mistake. The template was designed so that when you were assembling the harness, you couldn't actually access the part of the cable assembly where you could accidentally insert into the wrong location. And then we also wanted to take into account the possibility that maybe occasionally the plug would come from our supplier, or the harness would come from our assembly would come from our supplier without the plug. So those were the conditions. And then we started brainstorming which ones of those are we going to do. We absolutely wanted a prevent Poka Yoke. We didn't want to just detect it before it left. We wanted to prevent the possibility that it would occur. So there are those two different types of Poka Yoke, and preventing is always best. If you can think about it, we thought about the cost, we thought about the time to develop, and we also considered the fact that there could be multiple causes, and we'd identified a few of them. And this led us to the next step, to establish a couple of countermeasures. And on the left-hand side there, you see a template you can see right here is the spot where someone could insert a wire in that molded part and accidentally push the plug out. Well, we put a little pin there which prevented that from happening. Okay, and then we also so there's the plug, therefore you just can't push it out. We also wanted to test for the possibility that maybe this part wasn't present at all. This part right here, maybe it came in without that. Now, we certainly could have said, well, just do a visual on that, but we'd already done that. That didn't work. That was that problem of, you know, subjective inspection. Is it there or is it not there? So the next part of this was, the next countermeasure was to create a fairly simple device that indicated whether or not the plug was there at all. And it was the assembly device. So it was worked right into assembly. We had to have a device to hold this particular molded piece while we inserted the harness. And so this piece here prevented the cable from being inserted, but over here on this side we were sensing with a pin to see if in fact the plug was there in the first place. What these two steps did was they took all of the worry out of the process. The person who was doing the assembly could now do assembly, not have to worry whether or not they accidentally poked the wrong part of the piece with the cable or whether or not it was there. So the function was assembly, and now they were able to do assembly. And we got immediate feedback if from this fixture, a buzzer would sound if we sensed that that the plug was not in the molded piece. So then we put it in practice. We tried it, we ran it, and it worked. It worked. It absolutely worked. And that was the end of that problem. I should say it wasn't exactly the end, because at one point we subcontracted this work to another manufacturer, and they opted not to use the fixture, and then the problem recurred. So it's an unfortunate story, but the point is we had a reliable method, and this was all done using that process that I showed you earlier. So with the standardization and the improvement, we ended up with 0 defects. That's the idea. That's the technical part. And the idea behind that, the philosophy behind it, I've circled here, is never pass a defect. That's the idea. We should never pass a defect. The only acceptable quality level to a customer is 0. We may feel that that's impractical. As a supplier, we may think that that somehow or other there are diminishing returns to that, but the basic philosophy is when we put our customer hat on, the only acceptable quality level is 0, and when we pass a defect, that's a management sin. We've created a system where it's okay to pass defects if we say that anything above 0 is acceptable. Now, at the same time, these other points of philosophy, these 4 points of philosophy, incidentally, came from Taiichi Ohno's book, Toyota Production System, Beyond Large-Scale Manufacturing, which is a great book. It's the Bible. It's the book everybody ought to read. So the basic idea here is that we did do direct observation, but in this case, we absolutely required the trust and observation of the persons doing the work, because the mistakes, the inadvertent mistakes would occur once in a while, only once in a while. The people who would make them are the ones who would know when they occurred. Just tough to be watching all the time. Okay, so a person who's doing the work is there all the time. That meant that we needed to respect our employees. The people who are doing the work are not making mistakes because they're careless or thoughtless or don't have attention to detail. They're making mistakes because we've created a process in which it's possible to make a mistake. This was a critical part to the Toyota Production System, that if we needed to get to 0 defects, we needed to create a system in which it was not possible for those mistakes to occur. And that's the basic thinking beyond Poka Yoke. If you can't absolutely prevent them, you can at least prevent them from passing to the next process, and the means by which we do that then is these small changes for the better. So all those parts of the philosophy, they all tie together. So that kind of gets us to what I call the social science behind Poka Yoke. And Mr. Shingo, he's noted for, bringing the idea of Poka Yoke to the forefront. In his book Zero Quality Control and the Source Inspection and Poka Yoke Systems, was probably not the first time that mistake proofing was used. I think he copied it from the U.S. military, that we should have fail-safe systems. If they're going to fail, they should fail in the right direction. And but he recognized that there's human nature involved here. It was about humanity. We should respect the fact that people make mistakes. And he said that defects arise from undetected errors. And mistakes are part of human nature, but defects are not. And that was the basic change in thinking right there. And Shingo made this point over and over again, that we needed to create an atmosphere where we didn't beat people up for making mistakes, because then they just hide those mistakes. And we also needed to create an environment where they would we would ask people to let us know when those mistakes occurred, because those became, our gold nuggets. So this story, maybe some of you have heard this, but this kind of deals with the social part of this. Mr. Shingo heard the term Poka Yoke, which meant foolproofing, was used, and Mr. Shingo, writes about this, that if you're trying to get people involved in the process, you shouldn't probably be calling them fools. Now, I know the term foolproofing has kind of made it into it's an idiom in the English language, and maybe you could say it's inadvertent. It shouldn't be used anyway because people feel that. But idiot proofing, that's explicit. I mean, that's intentional. And when I hear that, it grates me, because I know that at that point, people are going to be hiding mistakes. They're not going to be talking about them. And that's the #1 reason that that Poka Yoke, I think, has not taken off, because the environment does not favor reporting those mistakes. We need to respect people's humanity, respect their intelligence. Fact is, by the time you've reached noon today, you've probably made 50 mistakes, most of them little mistakes, hopefully, but these things occur, and they occur because they can occur, because we're in a system where mistakes can occur, and if we're thoughtful about that system, we can design a good deal of those mistakes out. So hence the term mistake proofing. So in that regard, this goes back to, and I can't remember the exact year, but it had to be somewhere around 1992. I was at a conference out in Utah, and I was speaking to a fairly large group of engineers, and I was talking about Poka Yoke, and talking about, the fact that it's 100% inspection, and it should be simple, low-cost devices, and those types of things. And at one point, I used the expression, the cliche, to say, when I was talking about the simple devices, I said, it's not rocket science. And there was a murmur in the back of the room. And I continued on, but after my workshop, I had 5 gentlemen come up to me to let me know. They said, well, thank you, enjoyed the presentation. We'd just like you to know that we are rocket scientists. We're from Morton Thiokol. This was the organization that produced the O-ring for the Challenger. And in fact, they had a quality system, but at the time were lacking a quality culture. It was more important to them that they meet their schedule. So here is a perfect example when I say, well, why aren't problems reported? Well, because if the environment is not right, the problems won't be reported. Incidentally, Morton Thiokol went on at some later time to become Autoliv, no longer making the government stuff, but probably one of the best examples of continuous improvement in the U.S. So we all have opportunities to change, but when I talk about the cultural part of this, it's really huge, that you can put these tools in place, but if people are afraid to report problems, your problems are just going to grow every day. So what are some of the causes of this? Well, if we have an organization where, we're sort of siloed, there's us and them. I refer to that as they analysis. That when I hear the word they, and we're talking about problems, they say, somebody uses the word they, I have to say, well, who is they? Is it the people up in management? Is it the suppliers? Is it some department that's not your department? Who is they? Because a lot of mistakes occur in the boundaries, at the handoffs, because we don't have that type of good communication. That's part of that cultural change that's critically important to making mistake-proofing work. As we walked through that process earlier, the one of the harness assembly, that was pretty much determined in a single department. The work was being done in a single place. We made a point to go out and take a look at what was happening with the supplier and at some downstream operations, but in fact, it was fairly easy to see when we actually went through the process. Because it was contained, but a great many mistakes will occur crossing boundaries, and some of them are painfully obvious when we go to take a look, but since we don't bother to see what happens with the handoff, we kind of miss those opportunities. So if it's not your department, then maybe it's not something that you need to worry about. So, and I'd like to close with a short story. I was always told that when we found a mistake, it was a gold nugget. And I was a manager for a good many years in a manufacturing company. My first job was in marketing, and this was back in the days when cut and paste really meant cut and paste. And I was working with some artwork in the back room where the literature was. Accidentally left the box of pasted originals on the floor next to the trash, and the next day they were gone. They had already gone to the dumpster and out to who knows where. So that was the end of our artwork, and Lord knows why I wasn't fired that day, but I came pretty close because I'd made a mistake. I had inadvertently put some stuff off to the side and forgotten to move it back. Fortunately for me, my manager was forgiving and looked at it and said, yeah, well, that could have happened. It's pretty messy in the back there. It's hard to know what's what. That was probably my first experience, my personal experience with mistakes. So when I got into mistake proofing, and I don't know exactly where this idea came from, but I felt like whenever I'd see somebody making a mistake, I would get angry. When I make a mistake myself, I get angry. I get angry at myself. Probably get red-faced if I see a mistake, and I had to convince myself not to do that. So I developed a phrase, sort of a mantra for myself, that when I saw a mistake, I would say, thank you for making this mistake obvious. Thank you for making this mistake, because if someone as experienced as you could make this mistake, well, it must be happening a lot. So this is good. What can we do about it? What do you think we should do to fix this problem? And it seemed to work, actually. That was a good ploy. So I've been active with the Shingo Institute, formerly the Shingo Prize, for a long, long time, and I was out at a plant that was vying for the prize. I can't really say who, but it was an engine plant. They were making engines, and we came upon a process where at this particular point in time, the tolerance on the engine blocks and the pistons was problematical. That we had to match the pistons to particular engine blocks. So there was an elaborate process to make sure that oversized pistons would go with oversized engine blocks and so forth. And we were talking here about small fractions of inches. Millimeters, but fractions of millimeters differences. But of course, it was a big difference to you, the customer, because if you had an undersized piston in an oversized engine block, you would have, you'd have an engine that would die pretty quickly. And so I was watching this process where it was an automated process, and there was somebody who was pulling piston assemblies off of a material feed where there was probably maybe a dozen different gradations of pistons to match engine blocks, and it was all controlled by a barcode, and so that she should have been able to look at the specification of the engine block that was coming by on a conveyor, and she was going to match that then with the right pistons. So I watched this, and I was standing with her supervisor. My first thought was, boy, I said, I don't think I could do this job because I would make a mistake. I think this would be really challenging. And he said, no. He says, Bertha is very experienced. She's done this for many years, and she's never made a mistake. Well, you probably guessed where this story is going. While I was standing there, sure enough, Bertha made a fairly obvious mistake. You could see that the tolerance that was required for the particular engine block going by on the conveyor did not match the tolerance of the pistons that she loaded with it. And so the supervisor, kind of embarrassed, he stopped the line, had a word with Bertha, and then they fixed the problem and it moved on. The next morning, I was there with a team of persons from Shingo Prize at their morning staff meeting, and the supervisor introduced everybody from the Shingo Prize and said, this is Bruce Hamilton. I'd like to thank him for picking up on Bertha's screw-up. At which point Bertha kind of burst into tears, and I was as embarrassed as I think I've ever been. And guess what I said? Well, Bertha, thank you for making this mistake obvious, because if somebody as experienced as you could make this mistake, then it must be happening a lot. And it kind of turned that around a little bit, but that was the whole point. That's the point of Poka Yoke. We talk a lot about respecting employees and developing their capability, and my experience has been that every one of the techniques from the Toyota production system, whether it's pull systems or setup reduction or continuous flow or any number of different tools, become the means by which we create a professional challenge for employees to fix things, to improve things, to make things better. And in the process, they develop confidence. They develop confidence that they can do better, and they develop confidence that they can try things and not be called out by a supervisor who says somebody screwed up. Poka Yoke, for my money, is the most creative of all of these, because typically the person who is making the defect may be the only one who knows the defect is occurring. We tend to know about defects when they're really obvious. Like I was at an aircraft manufacturer, and this goes back quite a few years. They called me in to talk about Poka Yoke, and I said, "Oh, why did you have me in? What was the reason for this?" They said, "Well, somebody working late on one of our assembly lines flipped over a wing without without closing the interlock on the fixture, and the wing fell on the floor, and now we have an $8 million piece of scrap." So to their credit, rather than chastising the employee, they said, "Shame on us, we should have known about that." Point is, that was just one of millions of different things that go wrong, and because it was a real big one, we saw it. But the real mistake-proof opportunities are the little ones that get fixed by sleight of hand, the ones that slow people down, the ones that make people worry all the time because, did I count out 10 or did I count out 11? Did I do all the steps or did I miss a step? All those things that create frustration for employees, this is their opportunity to not only identify the spot at which the defect is made, but absolutely reduce the possibility of that mistake ever occurring again. Okay, that's why this is my favorite. This is my favorite of the technical part. It's also my favorite social part, because I think more than anything else, it shows respect for employees. So that's my take on Poka Yoke. I do write a blog once in a while called Old Lean Dude. I'd love to have you join in. I'm about to put another post up today. GBMP has a slogan, everybody, every day, which is, from my standpoint, the ideal condition. Everybody making improvement all the time. I think I've gotten to the end of my 45 minutes, so maybe I would turn this back to Jerry, and if you have questions, I'd be happy to try and answer them if I can.
Great. Thank you, Bruce. And now we will review any questions. So if you do have any questions, please submit them on the right side of your screen. And to start off, do you list all the defects on the Poka Yoke opportunity?
So yes, there could be multiple multiple defects. There could be multiple things occurring at the same for the same part. But I would say that's a good question. If there are multiple defects, then you probably need to track them through one at a time. For example, you could end up with a part where the defect was described. It was assembled backwards and it was missing a part. I probably would be inclined to track those in different trails. It's hard to fix general problems. It's nice to boil down to as specific a problem as you can.
Okay, great. Are the terms error-proofing and mistake-proofing the same as Poka Yoke, or are they subsets of Poka Yoke?
They're the same. They're the same. It's exactly the same thing. People make mistakes. Mistake is another name for error. In fact, I think error-proofing has become a more common name for it.
Okay, great. When trying to find causes, what tips do you have for balancing speculation? Like, it could happen this way versus observation, it was seen happening this way?
Yeah, so this is the tricky part. First of all, the best observation, the best information is going to come from the people who are closest to the process. And it is somewhat speculative, but if it's done in the right spirit, and people have hunches because they do this job all the time, that's absolutely your best information. I would not speculate. I wouldn't have people that are not part of that process doing the speculation. I already gave an example earlier in the presentation of speculation without observation, and we ended up producing like a dozen mistake-proof fixtures when we hadn't even determined it was a real mistake. So, and oftentimes persons will respond, I think this might have occurred. They're a little tentative. In fact, they may absolutely know that it has occurred. They're just a little bit cautious about it. So it may sound like speculation, but in fact, it may be something that was observed absolutely.
Okay. Do you find Poka Yoke tougher for a high mix, low volume manufacturing?
So, of course, high mix, low volume is a particular, that was my marketplace. We had hundreds of millions of possible combinations. The idea is to have many Poka Yoke devices. So if you have many people participating in this process, the opportunity for mistakes, may be greater in the high mix, low volume, but the opportunity then to reduce defects due to human error is also greater because of that mix. So it's a mixed bag. You're on a level playing field with everybody else in that high mix, low volume, to the extent that, and this is what I found, because that was the business that I was in, that there was just no end to the little things that went wrong or could go wrong, and having many people participate with those ideas made a big difference.
Okay, great. Is there a process to minimize mistakes on single piece production?
Well, single piece production, it's almost it's a prerequisite. If you were producing a single piece, you had best, that's when I go back to that philosophy where it said produce the customer's exact order immediately, and that implies one by one. If you don't have a defect-free process there, the system crashes. If you have 2 or 3 pieces, that kind of hides that problem's still there. But depending upon how you look at it, with the first time that I was able to test a one-piece line in my plant, people said to me, Bruce, this is the worst system we've ever seen, because now every single defect we have shuts us down. And I kind of gulped and said, well, I don't look at it that way. I think this is the best system we've ever had, because every single defect shuts us down. We got to do something about it. So Poka Yoke goes hand in hand with JIT. That one absolutely requires the other. And if you kind of look back through the Toyota literature, quality is sort of the prerequisite for everything. It's a prerequisite for continuous flow, for Kanban. It's just something which is a must. Mistake proofing, incidentally, can play a very big part in setup reduction. People who are doing changeovers on equipment fear mistakes. They fear crashes. And it's often because it's very easy to make mistakes. So, one of the slides showed a fixture which could only be mounted one way, and that was intentionally mistake-proof so that we could do a single-touch exchange of dies. If we hadn't done that, then somebody would always be checking, because they'd be concerned that maybe they set the die up backwards. So they absolutely go hand in hand.
Okay, great. What is ROI? Reliance on operator inspection?
Return on investment?
Okay, great, thanks. Can you give some examples from administrative areas where defects are not visible, like data error or information flow error?
Yeah, so often it's just and in fact, computer systems can be wonderful for validating information, so that we can't type in incorrect information, or we can't be missing information. You can take the word part and replace it with information in just about any administrative area. Most people, I started out, I mentioned my first job was in marketing, so I know mistakes can be made in administrative departments. The trick is just to sort of replace the term part with information. The same things are going to occur. Probably, within you take a look at the handoffs with information, it's amazing how much inspection is done by each downstream process. We receive a report, and the very first thing we do with it is we have to check to see if the information is complete and correct. Or maybe there's unnecessary information, and that kind of creates confusion for us. So there are lots of administrative areas where mistake proofing can be valuable. You know, often, for example, if you have a filing system where you can enter the same name 3 times, people will do it. If you don't have traps in the information to prevent that from occurring, it will occur, and that's why most of us, you know, can relate a story where we received the same piece of mail with apparently the same name, but we receive it twice.
Okay, good. At what point in lean maturity does Poka Yoke become a critical component?
Yeah, so as I said, it's part of Jidoka. It's one of the pillars. Like a lot of, that's a tough one to answer, because on the one hand you'd say, well, it's kind of part of JIT. It's something after you've achieved some stability and some standardization, and if you don't have a good standard, how do you know you're making a mistake? At the same time, I think there is that proverbial low-hanging fruit where people know that a mistake is occurring and they can think of a better way to prevent that mistake. It could just be changing the sequence of operations so that that mistake doesn't occur again. So I think that from the standpoint of respecting employees, the sooner we can create an environment of trust where if a problem has occurred, they're going to be reporting a problem, whether that problem deals with instability or deals with falling off a standard or deals with making a mistake. The sooner we can do that, the better. In my own case, I guess I was just naive about it, but Poka Yoke seemed to be a great way for people to contribute. You know, I said, the slogan of our organization is everybody, every day, and we'd like to have everybody contributing, and guess who knows where the mistakes are? You know, it's typically not the engineers. You know, that's one of the funny things that happens. Oftentimes when I'm asked to talk about Poka Yoke, I get a room full of engineers. Now, there's nothing wrong with that. I love engineers, but at the end, usually one of the discoveries at the end of the workshop is, boy, we should have had some more frontline people in here saying, well, yeah, exactly. So this is a great opportunity for engagement. I'd say early along in the process makes sense.
Okay, great, thanks. And in your experience, have you been or seen a process that was mistake-proof to a place where QA inspection was not required?
Yeah, that's basically Mr. Shingo's, I think his entire intent was that if you could inspect the source of the problem, that's what he meant by source inspection, that this would eliminate the need for you know, for, let's say, that downstream quality control inspection. That was his whole thing. You know, the idea of eliminating the silos, being able to confirm quality at the source, not waiting for a third party to confirm the quality. And the Poka Yoke device was an objective device. It was inspecting the part or information or service in exactly the same way your customer would objectively inspect it. And if we did that, then it was not necessary to pass that along to a third party for inspection.
Okay. Is the pick-to-light system considered a Poka Yoke?
It's kind of an elaborate Poka Yoke. It directs people to always pick the right part. I had that little cardboard template over some blue bins that accomplished the same thing. But I think the intent of the pick-to-light was if we followed the sequence of that, and we would always pick the right parts, we would be less likely to be picking parts that were wrong. I guess you would say yes, yeah.
Oh, okay, great. What details can you provide about conducting a Poka Yoke countermeasure determination? How many people, how long would it typically take, etc.?
Yeah, so there's a wide range. Oftentimes, mistake-proof devices can be accomplished in an afternoon and for $1 by production associates if they know where the problems are and they know that they can make a simple change in the process. Sometimes just reordering the process can make a big difference, and that can be done without a lot of other participation. If it's not something that affects the fit, form, or function, if it does, then this probably involves people from the floor plus an engineer, somebody who understands the function of the part. Because it may involve, if it's manufacturing, may involve somebody who is good with fixturing, who understands how to put those pins in the right places so the parts can only be mounted in one way. If it relates to information, it probably involves somebody from the IT department. So it has to be in context of the, of the work that you're doing. Last year sometime, I went to the gym and I left the key to my lock, which also was my car keys, in the locker and then locked the lock. And so the sequence in which I did that made that possible. Now I always have that lock locked. When I'm done, I push the lock back together. That means the only time I have that lock in my hand with the keys is the time when I need to open it to lock my locker. So I get both the keys and the lock, and I cannot put those keys in the locker because I'm using them to open the lock so I can lock it. That's a simple example of changing the sequence of an operation so that you can't make the mistake of accidentally leaving your keys in a locker. You see these things over and over and over again, and people's creativity is what gets into it. First of all, they got a problem, and then they can use their creativity. So Mr. Shingo's point that it should be simple and low cost was really important. Too often we turn these things into machine vision, and sometimes that's okay, but 9 times out of 10, that's not necessary. You can do something simple.
Okay. What techniques or approaches would you suggest to engage the direct workforce when entertaining an application of Poka Yoke?
Well, it kind of depends upon the environment that you're starting with. If you're starting with an environment that, I guess the general answer is always look for a struggle. If you've got somebody who's having a struggle, and maybe that person who has the chutzpah to talk about it, then you want to go and work with them. And this business of conveying the fact that the mistake was really that's a management issue. We created an opportunity for you to make a mistake. Let's see what we can do to work it out. I guess I'm saying is engineer a small victory. Make a point that a mistake was made and that you found a way together to correct that mistake, and let that kind of tacit learning kick in. So you now have support from somebody on the floor. I made a mistake, but I wasn't criticized for it. I didn't get a warning to be more careful or some sort of a retraining. We actually used this method, and it worked for me. You need to develop that tacit learning, and it typically happens one person at a time, and then after you get a few under your belt, people begin to believe that, yeah, I have a lot of those mistakes too, and now I see that there's a means, and more important than that, I see that there's an environment where I can do something about it, and I'm not going to be blamed for it.
Okay, we have time just for one more question, and it is, how do you correct a defect that was fixed with a mistake-proof device, but it keeps occurring?
So I would say that if you have a mistake-proof device that's supposed to correct a defect, then you haven't the device. First of all, I don't know that we've gone through all the steps. I'm a little puzzled by the question. Mistake-proof device that doesn't correct a defect. That probably means we haven't found the root cause, doesn't it? Mm. It could mean a lot of things. It could mean that your mistake-proof device, maybe it's a device which is supposed to protect that you always assemble things at a right angle, so that and the device is a little out of calibration. I don't know, but I'm not sure how I can answer that question. if you put an objective device in to prevent a mistake from occurring, and the mistake and the device is, you're still getting a defect, then I'd say your plan, do, check, act cycle needs to kick back in. We need to go back and take a look at why.
Okay. Okay. Unfortunately, we've run out of time for additional questions, but any questions that we did not review, I'll send them to Bruce and email a response back to you. And thank you, everyone, for participating and for understanding. And thank you, Bruce, for a very insightful presentation. This brings our webinar to a close. Our next scheduled webinar will be on Thursday, February 18th, titled Building the Fit Organization with Dan Markovitz. Please visit AME.org under the AME Events and Training tab for more information and to register. Please don't forget to fill out the short survey that will be in your inbox. Thank you, everyone, for attending, and have a productive day.